Hi, welcome to my video on solving distance problems. Just a reminder, due to units in the section on Algebra 1, one unit is writing an expression with a single variable. The second one is solving linear equations with a single variable. Both of these units should be done before solving word problems. Just a reminder, do those two units first. Solving word problems will be much easier. This video is on distance, and distance equals rate times time. And we could call it R times T, or just RT. Calculate the distance for each. We have a rate of 70 kilometers an hour, and the time is 2 hours. So what happens if you multiply those two? The hours cancel, and you get 70 times 2, 140 kilometers. 44 miles per hour, you drive for 3 hours, and you multiply, hours cancel, and you get 132 miles mi. Write an expression for each distance. Again, we have a rate and a time to give us distance. When we multiply, the hours cancel, and I get 4 times x, which is 4x centimeters. And the rate is 7 feet per second, and x feet. We're going to multiply these two. The seconds cancel, and I get 7 times x, so 7x feet. And we're multiplying again, rate times time to give us distance, and the hours cancel, and we get 5 times x plus 10. I could have wrote down x plus 10 times 5, but it's easier, or it's better in math, to put the 5 in front of the binomial. And you could also write it as 5x plus 50, because 5 is multiplied by the x, and 5 is multiplied by the 10, so either or. Just a little review on the distance formula. Distance equals rate times time. We're going to use that in all of our problems. Let's do an example. 2 trucks traveling in opposite directions from the same location on a highway. One truck drove 15 kilometers an hour faster than the other. Both trucks drove for 5 hours. If there are 675 kilometers apart, how many kilometers did each drive? Well, sometimes when you're doing these, people will they leave from the same location on the highway. So let's go to the right, and let's go to the left. So they're leaving from the same location. So this could be truck 1, and this could be truck 2. And when we're doing these also, we remind us that a lot of times people set up the box as they did in age. And I'll show you how to set up the box. But before we start, let's look over the information. One truck drove 15 kilometers faster than the others. Both drove for 5 hours. So, and they are 675 kilometers apart from here to here after driving for 5 hours. So let's do this one and say that's the trucks. So we got truck 1 and truck 2, and we have the trucks have a rate or a speed, whatever you want, to make a difference what you want to call it. And the trucks have a time, and they come up with a distance, which is distance is rate times time. So let's see. Let's say truck 1. One truck drove 5 miles, 15 kilometers an hour faster than the other. So let's let one truck be x, and the other truck is faster, so it's x plus 15. And it says they both drove for 5 hours, so 5 hours is for both of them. And we know that the distance is rate times time, so 5 times x is 5x. 5 times x plus 15 is, we could have said if we wanted to, 5x plus 75. And this is the distance they drove, so the total distance there is, let's write down the equation, the distance from T1, off T1, the distance of T2 is, and together the two distances add up to give you 675. And we're dealing with kilometers. We'll solve the equation. 5 times x, 5x, 5 times 15, 75. Done. Simplify the left side. Add the x's, 10x plus 75 equals 675. 10x equals 675 minus 75, because the variables go on the left, numbers go on the right. When you move the 75 over to the right, it becomes negative. 10x equals 675, subtract 75 is 600. Divide by 10, and we get x equals, zeros cancel, we get 60. So one truck is, that's T1, and T2 is x plus 15, write that down below. X plus x and x plus 15, there they are. So x is 60, 60 plus 15 gives us 75. So truck 1 is driving a distance of 60. The other truck is driving, or should I say, x is the rate. So truck 1 is driving at a rate of 60, and truck 2 is driving at a rate of 75. And we know, let's just check now. Check to see if we're right. T1 and T2. T1 is 60, T2 is 75. So that this obeys, this one truck drove 15 kilometers faster than another. So that's okay. That's the first condition. And their distance. So truck 1 is driving at 60 miles an hour for 5 hours. So that's 60 times 5. So that's 300 kilometers. And they're driving at 75 miles an hour, truck 2 for 5 hours. And that gives us 375 if you multiply. And when you add that up, you get 675, which is the total distance. So we're correct. So one truck drives a speed of, how many kilometers did each drive? So we had to get the time, we worked these out. So one truck drove 300 kilometers, and the other truck drive 375 kilometers. Make that a 3. So we're asked not just to find the speed, we had to find the distance each drove. So we had to really work out the distance formula for each one. Okay, let's do another one. Now in this one, I call it practice. You can pause the video and see if you can work this question out. When you get it done, play it back. Let's read. 2 cars drove towards each other at the same time from a different town that are 270 kilometers, 270 miles apart. So we got 2 towns, town 1 and town 2, and the 2 cars are leaving at the same time and they're driving towards each other. Okay. And the towns are 280 miles apart. That's the distance between the 2 towns. So that means we're dealing with adding the 2 distances up to get to 280. One car travels 10 miles per hour slower than the other. If the faster car drove for 3 hours and the slower car drove for 2 hours, find their speeds. Well, again, let's set up a little table. Let's see what happens with the table. Here we go. I like doing the table for distance and age. And call this the cars. So we got car 1, we got car 2, and one car is slower than the other, so we'll come across that. We got a rate, we have a time, and rate times time gives us distance. So here we go. Now it says one car traveled 10 miles per hour slower than the other. So if car 1 is X, the other one is slower, so it's X minus 10. Take off 10. Now, the faster car is T1, the slower car is T2. So that's important because it says if the faster car drove for 3 hours, so the faster car is T1, which is X, drove for 3 hours, and the slower car drove for 2 hours. Okay, there's the 3 for the faster car, 2 hours for the slower car. The distance is the rate times the time, so that's 3 times X. And distance equals rate times time, so it's 2 times X minus 10. And again, the sum of the two distances, the distance of car 1 and car 2, you add up these columns here. You add up X, add on 2 times X minus 10, and that distance is 280. And we have to simplify, so simplify the left side. Done. 2 times X, 2 times negative 10, negative 20. Add up the X's, 5X. Remember, when I'm solving, I like to simplify each side completely before I transpose. There's only one X, so that stays on the left side. And the minus 20 goes to the right, become plus 20. So 5X equals 300. Divide by 5. And X equals 60. And remember, X is the rate now. That's what we're working on. And so we have X minus 10. So 60 minus 10 is 50. So the fast car is going at 60. The slow car is going at 50. So that's the fast car. Obviously is 60. That's the slow car. And that's T1 and T2. And we got to check to see if we're doing okay. Here we go. This is the fast car. Let's say the fast car and the slow car. So the fast car is 60 miles per hour and the slow car is 50. That's miles. Yep. So that's miles per hour. Just make sure. And the time of the fast car. So one car is 10 miles an hour slower. That's good. 50 is 10 less than 60. And now the time of the fast car is 3 hours. So 60 times 3 is 180. And the speed of the slow car is 50 and is driving for 2 hours. So 50 times 2 is 100. And if you add the distances up together, it's 280 miles. Remember, rate times time, that's a distance. It has miles there. It has miles. So that checks. So everything checks, and we got to find their rates. So the fast car's speed is 60 miles per hour, and the slow car speed is 50 miles per hour. Okay, how'd you do? Did you get it right? If you did, great. Let's try another one, an example. This time, what's happening? We're moving in the, let's see. A person drove from city A to city B. So city A to city B for a certain period of time at 80 kilometers an hour. So they went from A to B. Driving from city B to city A, so now that means they're doing the return trip. So notice in the return trip, so what we have is the same distance. So the distances are the same for both of these. The speed was 40 kilometers an hour more, resulting in time of 2 hours less. Find the distance between the two cities. So we're going one way, then returning, but it's the same distance. D-I-S-T. Remember my spelling, gotta watch it. We're going the same distance, not the same direction. Okay, let's see. Obviously, I'm going to say obvious, I gotta be careful. When you're going faster from one place to another, you're going to get there in less time. That should make sense. So again, let's set up the box. Or do we need to set up a box? Well, we can, I suppose. We can go one way and then go another. So this is, I'll say way or direction. And we have a rate. We have a time. And we have a distance. So this is going one way. This is the return. And this is the start. We call it start, initial. So when they leave to go over the start, they went at 80 kilometers per hour. Okay, there's 80. Driving from city B to city A, the speed was 40 more kilometers per hour. So that's 40 onto that is 120, resulting in 2 less hours. So if we let X be the time it took to go over, and if you go faster, then you're going to go 2 less hours. So that's the speed going one way. Returning, you're going faster, so you're going to have less time. So the distance is rate times time, which is 80x. And we have rate of 120 times the time, x minus 2. And this time, the two distances are the same, so that means 80x is equal to 120 times x minus 2. The two distances are the same. We have to simplify 80x equals 120 times x, 120x, 120 times negative 2, negative 240. So the x's go to the left, so it's a minus 120x. The negative 240 stays. Add, that's a negative 40x equals negative 240. Divide by negative 40. Cancels, so x equals 6. 24 divided by 4 is, that's a 40 now. Okay, be careful, that 40 here, 40 there. The zeros cancel, I get a 6. So that's going one way, and returning x minus 2 is 6 minus 2 is 4. So 6 hours go over, 4 hours to come back. And it says, find the distance between the two cities. Well, let's check first. We have, let's see, we have a time is 2 hours less. So if we have going one way, the time is 6, returning is 4, so that's 2 hours less. And the speed, let's get the distance. So if that's an x, so that's 80 times 6 going over, so that's 480. And we have 120 times 4, which is the speed returning, times 4 hours is 480. So the distances are the same. And the question here is, what's the distance between the two cities? So the distance is 480, and it's in kilometers. So 480 kilometers is the distance between two cities. Okay, let's continue. Distance problems, word problems, always, the more you vary the information, the better you begin to understand. Another one. From an airport, plane A left 3 hours before plane B. Plane B flew 120 miles per hour faster than plane A. Both planes flew the same route. Plane B flew for 5 hours before overtaking plane A. What is the distance? What distance did each plane fly? So what we have is, again, plane A left an airport and flew in a direction. And then it says 3 hours before. So that means plane A is out in the air flying before plane B ever leaves the airport. And that's important because whatever plane B is flying, plane A is going to be 3 more. Plane B flew 100 kilometers faster. So if plane A, there's plane B leaving, and it's going 100 kilometers faster. So this one is X, plane A is X, plane B is faster, so it's X plus 120. And it says plane B flew for 5 hours before overtaking it. So the time for plane B is 5. That means the time for plane A is 8, because when plane B left, A was already 3 more hours in the air flying. What distance did each plane fly? But obviously, the distance is the same distance, because when the two planes, when plane B catches plane A, they would have both flown the same distance. So if you want to set it up in a box, we can. Go again. Here we go. Set it up in a box. We got a plane. We got the rate, we got the time, and we got the distance. So the rate, time. I already did all that here, so I'm just doing it again just to make sure. You can do either or. So we have plane B and plane A. So we can say plane A and plane B. Let's see. Plane B flew 120 kilometers faster than plane A. So plane A is X, plane B is X plus 120. And if plane B flew for 5 hours, plane A is for 8 hours, this is 3 more. So the distance is rate times time, so that's 8x. And the distance is X plus 120 times 5, so it's 5 times X plus 120. And they flew the same distances, so that means we can go 5 times X plus 120 equals 8x. I could have put 8x first and 5 times X plus 20 second. Multiply, get rid of the bracket. I have 600. And when I move the X over to the left, it becomes negative 8x. 600 becomes negative 600. And that gives me negative 3x equals negative 600. Divide by negative 3. Cancels. X equals 200. And the other plane is flying at 120. So 200 plus 120 gives me 320. Now let's see. So this is X is plane A. B is X plus 120, and is asked to find the distance each plane flew. Well, let's check to see if the time. Well, we get the distance by checking. We probably get the distance. Here's plane A. Here's plane B. So plane A was flying at a rate of 200, and plane B was flying at 320, and it's miles per hour is the rate. So plane A flew for 5 hours, so 200 times 5 is 1,000. Plane B flying at 120 more, but flew for 8 hours, so that's 120 times 5. Let's see, we're working on the rate, and that's plane A is 8. I was wondering why I had them reversed there and I couldn't get the answer. So that's a 1600, and that's a 5, and that gives me 1600. Now we're okay. plane A. When I looked it up, I picked up the 5 instead of the 8. So plane A is flying for 8 hours at 206. Both of them are flew 1,600 miles. So the distance, the distance is 1,600 miles. So you got to be careful. Remember, the two of these had to be the same distance. So by my putting a 5 here and an 8 here, they wouldn't have been the same. Okay. Let's continue. Practice. You know what practice means? You can pause the video and work the problem out before I work it out to see if you're going to get it right. Plane A flew for 2 hours more at a speed of 120 more than plane B. So plane A flew for 2 hours more at a speed of 100 kilometers per hour more than plane B. Plane B flew for 6 hours. If there is a difference between the two planes of 1,800 when they fly the same route, find the speed of each plane. Okay, let's see what we're saying here. Again, set up the check box. Always good to do the box. We have a plane A and a rate and a time and a distance. So this is the plane. This is the rate. This is the time. And this is the distance. And let's see, it says plane A flew 2 hours more and a speed of 100 more than plane B. So let's start with plane B because plane B is on the right, and then have plane A. So if the rate of plane B is x, then the rate of plane A is 100 kilometers an hour more, so it's x plus 100. Plane B flew for 6 hours, so 6 hours. Plane B flew for 6 hours. Plane A flew for 2 hours more, so 6 plus 2 gives me 8. Now we have the rate done and the time done. Distance, rate times time is 6x, and the rate times the time is 8 times x plus 100. So I get the distance for plane B, distance for plane A, and there's a difference. So we have a difference. That means we have to subtract. But do we write down 6 minus 8 times x plus 100 equals 1,800? Or do we write down 8 times x plus 100 minus 6x equals 1,800? Well, it makes, if you think about it, plane A is flying faster and more time. So plane A is the faster plane. Plane A is the faster plane, more time. So plane A is going to fly further. So therefore it must be the distance that plane A flew minus the distance that plane B flew. Again, plane A has got more speed and more time. More speed, more time means it's got to be flying further. So we do a subtraction. So 8 times x, 8 times 100, minus 6x equals 1,800. Group the like terms. I'm grouping the like terms. But if you wanted to, you could have just added those two right away and got 2x plus 800 equals 1,800. So I like to group the like terms and keep everything consistent. So 2x equals 1,800 minus 800. 2x equals 1,000. Notice 800 becomes a negative when you move it to the right. Divide by 2, and I get x is 500. So if x is 500, that's plane B. This is plane A, which is x plus 100. So 500 plus 100 gives me 600. It says find the speed of each plane. Boom, we have the, what's x? X is the speed, we have it. But let's just check. Make sure. Plane B, plane A, we got plane B is 500, and again it's kilometers per hour, because that's the speed. plane A is 100 more, so that's kilometers per hour, done. And the distance, so plane B is flying for 500 for 6 hours, so that's 3,000. Plane A is flying at 600 for 8 hours, so that's 4,800. And you can see that the difference between these two is 1,800. 1,800 is the difference between these two. So that's right. So the speed of each plane, so plane A has a plane A speed is plane A is 600, and we have again 600. We're asked to find speed, so it's kilometers per hour, and plane B speed is 500. And again, I could have wrote down plane B first, 500, plane A, 600. So notice the little twist is a little different, but the box is always good to do. Now we have another one, the last one to do. Practice, pause the video, and work this one. Read it over and see if you're going to work it out right. Just be careful. A walker at 3 miles per hour is followed by a runner 2 hours later on the same path. After running for 4 hours, that's the runner is running, because we got a runner and a walker. After running for 4 hours, they meet. Find the speed of the runner. So we have a walker that's going out on the path. So there's the walker. And on the same path, we have a runner. And they're not going opposite directions, they're going in the same direction. So walker has got a rate of 3. So the rate of the walker is 3 miles per hour. It's followed by a runner 2 hours later. So that means the walker is going to have a time of 2 plus whatever because if the walker starts off, it's 2 hours ahead. So this is a plus. We got to find out what the runner is doing. So it says find the speed of the runner. So the speed of the runner, we don't know. But the runner, after running for 4 hours, so the runner is running for 4 hours and he meets up with the walker. So the time of the runner is 4. That means if we go back to the walker is already 2 hours ahead. So the time of the walker is 6. And notice they meet, so we have what we call, it's not the total distance, they're walking this, they are both doing the same distance. So rate times the time for the walker. So the walker is doing 3 times 6, which is 18 miles. And the runner is doing 4 times x, and which is 4x. Okay. Now, we could do a box if you wanted to do it that way, or we can set up a box. Let's just set up a box and see what happens. We have a box, we have the walker and the runner. We have a rate, we have a time, and we have a distance. So the walker is running at 3 miles per hour, and we don't know what the runner is doing. This is find the speed of the runner, so that's x. The time of we know the time of the runner is 4, and the walker is 2 hours ahead, so that's 6. So the distance is rate times time, so that's 18. And the distance here is rate times time, which is 4x. So that means they're the same distance when they meet each other. So 4x equals 18 divided by 4. And I get 4 into 18 goes 4, and 2 over 4, which is 4.5, which we could call 4.5. And the speed of the runner, so speed of the runner is what we had to find. X is the speed of the runner, and it's in miles per hour. So We're going to check to see if we're right. We're going to check to see if we're right. Let's see. This is the walker and this is the runner. So the walker is walking at 3. The runner is at 4.5. The time of the walker is 6. The time of the runner is 4. So rate times time, that's rate. So that's miles per hour. And that's 6 hours. And that's miles per hour. And that's 4 hours. So rate times time is 18. And rate is 4.5 times time, which is 4. 16. 4 times 5 is 0, so that's an 18. And that's equal. So the speed of the runner is 4.5 miles per hour. Notice I always write out a statement at the end of each problem I do to make sure that I'm answering the question. And I set up if I'm right. But if you're doing a lot of word problems or a lot of questions on a quiz, you can't normally check everything every time because you want to finish your test. Anyway, that's a video on distance. Hope you enjoyed it. If you did, click the like button. Click the subscribe button if you're not a subscriber. Click the notification bell because there are more videos coming your way. Write a comment on my video if you're a subscriber. And visit my math website, mathfullyexplained.com. There you'll find 3 sections: me, my degrees and teaching experience. Section on video talks about the strategies and the hints that I'm going to use to help you learn your math. Section on content has the units and the number of videos on each unit. The black font is what's online right now, and the red font is what will be there in the near future. Thank you for reviewing my video. Bye-bye.